mining. You probably think of big machines, brute force, right? Well, today, we're going to talk about how AI is stepping in to make one of the world's heaviest industries a whole lot smarter and way more efficient.
Okay, to really get a grip on the problem here, you have to start with this one kind of shocking number. Almost half of a mine's entire energy bill is spent on just one thing. It's called comminution, which is really just a fancy word for crushing giant rocks into smaller and smaller pieces. It's a huge, power-hungry beast.
So, what if that whole brute force thing is just old news? What if you could bring some real intelligence into the mix and get the exact same results but with way, way less energy? That's the big question we're digging into.
All right, so let's really get into the weeds of this energy problem. I mean, why is the old way of doing things just so incredibly wasteful? The best way to think about it is like this. Imagine you're driving a car, but the gas pedal only has one setting, floored, pedal to the metal. It doesn't matter if you're going uphill, downhill, on a smooth highway, or a bumpy dirt road. You're always at full throttle. That is basically how these traditional rock crushers have been working for decades. They get set to one power level and just run. They don't care if the rock is super hard, or soft, or wet.
And, this one-size-fits-all approach just creates a whole mess of problems. First, you're wasting a ton of energy by overgrinding everything. The system is totally rigid. It can't adapt on the fly. Maintenance, it's completely reactive. You're basically just waiting around for something to break. On top of all that, you're at the mercy of the grid when energy prices spike, and you've got all this valuable data just sitting there, completely unused.
So, okay, that's the problem. What's the fix? Well, it's not just a tweak, it's a total shift in mindset. It's about moving away from that brute force and moving towards something much smarter, intelligent, adaptive control. And the answer is what's called a closed-loop system. Basically, it's a system that's always learning and getting better on its own. Picture this. Sensors are constantly gathering data. An AI brain crunches that data and makes a split-second decision. The machines then do what the AI says, and here's the key part. The results of that action are immediately fed right back into the system, making the next decision even smarter. It's a cycle that just keeps getting better and better.
Now, this whole smart system is built on three really cool ideas. You could call them three superpowers that all work together. Let's break them down.
First, you've got the AI brain. This is the heart of the whole thing, and it really has two big jobs. Part of it is a fortune teller. It predicts how much energy is going to be needed down the line. The other part is the pilot, a deep reinforcement learning agent that's constantly tweaking the controls, making tiny adjustments to the mill speed and the amount of rock going in, all to squeeze out every last bit of efficiency, in real time.
The second superpower is the digital twin. And this is awesome. Think of it like a hyper-realistic video game of the entire mine. It's basically a flight simulator, but for crushing rocks. So before the AI's brilliant new idea gets sent to the actual, multi-million-dollar machinery, it gets tested out in this safe virtual world first. This way you know it's going to work, and more importantly, that it's safe.
And the third superpower? Green fuel. The whole system is hooked up to its own little power grid with solar, wind, and batteries. But here's the thing, this isn't just about being eco-friendly, it's about being smart. The AI knows exactly when the sun is shining or the wind is blowing, meaning clean energy is cheap and plentiful. So what does it do? It schedules the really heavy-duty, power-guzzling work for those exact moments. You save money and you cut emissions. It's a win-win.
So how does this all work together in practice? Well, it's a super fast loop. Step 1, data pours in from hundreds of sensors. Step 2, the AI brain instantly analyzes it and comes up with the best settings. Step 3, the digital twin runs a quick simulation to make sure the plan is safe and effective. Step 4, the go command is sent to the real crushers. And finally, Step 5, the system measures what happened and learns from it, making the AI even smarter for the next cycle, which happens like seconds later.
Okay, so that all sounds great in theory, right? But what about the real world? How do you actually roll something like this out? And the big question, what kind of results does it actually deliver?
Yeah, this is definitely not a flip the switch and pray kind of deal. It's a really smart, phased rollout over about 30 months. You can see they start small, just getting a baseline. Then they bring in predictive maintenance. After that, the AI comes online, but just in suggestion mode at first, like a helpful co-pilot. Only then do they fully integrate the digital twin and the renewable energy. This step-by-step approach is great because it lowers the risk and proves its worth along the way.
And the results? The payoff here is just enormous. We're talking about a 40 to 50% drop in the energy used for grinding.
Just let that sink in for a second. That's potentially slicing the energy bill for the mine's biggest power hog almost in half.
And what does that look like in terms of money? Well, it translates to about 13 to 15 crore rupees in savings every single year. That's a huge return, and it's all just from using energy more intelligently.
And look, it's not just about the bottom line. This project also slashes CO2 emissions by 30%. That's a massive win for the environment and for the mine's overall sustainability goals.
But maybe the most mind-blowing number is this one. The report estimates that even with the big upfront cost, the whole system pays for itself in less than 2 years. After that, it's all gravy, just pure savings and efficiency, day in and day out.
All right, so let's pull back for a second. This is clearly a game changer for this one mine, but what does it mean for everyone else? What are the bigger implications here?
Because really, this isn't just a story about mining. This is a blueprint. It's a model for any heavy industry that uses a ton of energy. We're talking about cement, steel, chemicals, you name it. It's a fundamental shift away from just reacting to problems and towards being proactive, dynamic, and genuinely intelligent.
And that leaves us with one big final question to think about. When you combine smart AI, safe virtual testing, and clean energy, are we actually looking at the new normal? Could this be the intelligent foundation for the future of all heavy industry? It really makes you wonder.